Hi everyone. Okay, so I'm going to start off by explaining a little bit about imagination. We're quite an old company in the context of technology. We've been around since 1985, and we are based originally in UK, and now we have offices all around the world. We're at the stage of having more than 800 employees worldwide as of this week, and we've expanded tremendously in the last few years. We're now the number 3 design IP creator in the world. Imagination, as I say, is an IP designer. We design hardware. We design the little bits of the core, little bits of the chip that are put into the end user products that you use every day, including products by Samsung. We are very specialist in mobile and handheld technologies, and increasingly in other markets. And so we have 2 main divisions. We have a consumer product division, which takes the designs that we've created in other parts of the company and delivers those to consumers, and that's in the pure digital radio business. That's been very successful, especially in Britain. But today I'm going to talk about the technology division, and this is system-on-chip IP. We have 4 main sections. We have Insigma, which is comms and other broadcast decoders and coders. We have Meta, which is general purpose computing and signal processing. And the Meta technology supports the PowerVR technology, which is what I'm going to talk about today, which does video processing, that's encoding and decoding, and also the PowerVR graphics, which is where I work, which is enabling the kind of rich 3D applications that you can achieve on platforms such as bada today. As you can see on the right-hand side of this slide, we have deals, we have licensed partners who are at the top, and that's with most of the top system-on-chip companies in the world. As you can see right at the top there in the middle is Samsung. Below that section is some of our OEM partners, these guys who actually make the phones or the portable media players or the set boxes. And as you can see again, Samsung are in there. And so Samsung has been a good customer and partner for Imagination over the years. So, as I say, the message we're trying to get across this year is that we provide something in almost every part of the mobile domain, and this allows our partners to incorporate clever, well-designed technology which has a proven record together to make a strong system-on-chip design. This translates into successful devices which then create happy customers, and this feeds back to us, and we take the feedback from the customers, from the OEMs, from the semiconductor manufacturers, and that allows us to make even better IP for the next cycle, and this goes on, and we've done very well from that, and so have a lot of our partners. So I work for the PowerVR graphics division. Our previous technology, PowerVR MBX, was incorporated into over 100 phone designs, and was very successful indeed. Our current technology, PowerVR SGX, includes programmable hardware. This is OpenGL ES2 level support, and this is allowing developers like yourselves to take the exceptional power that's available in these GPUs and in the phones under environments such as bada, and produce the really rich dynamic content that today's market really demands. As you see, there's a lot of devices here. There's over 200 with PowerVR technology now, 75 with PowerVR SGX, and we've sold over 400 million units worldwide of PowerVR hardware now. And as you can see, right in the middle center, the Samsung Wave with bada environments is there. It's very strong, and it's a first-class platform for Power BI. Now, we produce hardware IP that helps system-on-chip manufacturers, the silicon vendors, but we don't just leave it there. We provide them with reference drivers so that they can implement the chips successfully, and so that the devices can support great performance. But above that, we also provide developer tools in the form of the Power BI Insider SDK. And this is something I actually work on myself. Now, the idea of this SDK is to support development in all of its phases. A typical 3D application is shown on the screen here. You take your 3D assets, your meshes, your models, and your animations. You will want to export these into an optimized deployment format. You want to combine these with well-drawn textures, which are in efficient formats for the mobile devices. Once these are exported into the form that you can actually use, you will want to prototype and begin coding your applications in a friendly and nice environment. From there, you'll want to simulate, whether it's in the bada simulator or in our own emulation environment, so that you can iterate faster through different versions of your applications to get the best results you can. And then deploy onto the final platform and optimize, analyze the performance of your applications so that you can, again, iterate and produce the best performing applications that you can from a performance standpoint and also from a power saving standpoint. One of the very important issues for mobile graphics, and especially for imagination, isn't just the performance of the chips, it's the power usage. And our unique design is inherently suited to this kind of power saving quality. And it's part of the reason we've been so successful in the mobile space. Now, the Power BI Insider SDK aims to provide a solution for every step of this cycle. We have geometry exporters from the major 3D tools. That's Autodesk 3ds Max, Autodesk Maya. We have a Blender plugin as well, if you don't want to go with commercial offerings. We newly have support for Maya on Mac, so it's not just on Windows anymore. We also have a tool called Collada to Pod. Collada is the Kronos interchange format for models. Almost every 3D modeling package can export to Collada, and so we provide this utility to take that interchange format and translate to our own format called Pod. Now, Pod is a deployment format. It's not an editing format. It's stripped down to the bare metal. You can decide exactly what's in this file. It has features like animation compression. There's triangle sorting algorithms in the exporters, so that this format is as lean and mean as you can get onto your phone to be rendered using our Power BI technology. Incidentally, it's also very suited to other vendors' technology. It isn't some kind of special black magic whereby if you use it on a different phone, it will work. It's a very useful and versatile format, and we developed that ourselves so that we could support our own platforms, and we use it extensively internally, and a lot of major games companies use this format too. Now, to go with your models and animations, you need textures. You need 2D images. And so we provide a PBR Textil, which is a utility which will optimize your textures. In 3D graphics, bandwidth use is incredibly important. The data that you shove from your main memory to the graphics processor is the amount you can do with that is very finite, and you want to minimize that as much as possible. So if you can compress your textures, you save a lot of memory bandwidth, and this is very important for performance and also for power consumption. Accessing memory costs power. So PBR Texture gives you access to PBRTC compression, which is Power BI's own format, and this is available in 2 flavors. That's 2 bits per pixel and 4 bits per pixel, and this gives us 16 times or 8 times reduction from an uncompressed texture. Both of these formats support full alpha channels as well, so there's no compromises that need to be made in the kind of textures that you want to export. Obviously, PBR also supports all the other formats that are available under OpenGLES, and it even does some useful operations like make normal maps for you, or to add borders, the kind of useful stuff that maybe isn't available so easily in something like Photoshop. We also have an exporter for Photoshop, so if you want to go directly from your image editing package to our optimized formats, you can do that. And we even provide a library version of the text tool that's known as PBR Text. So this is the actual library that the GUI and the command line versions of our tool uses under this, the hood, and this can be integrated directly into your tool chains. So once you've combined your models and your animations and your 2D images, the next step is to start trying to prototype what your application is actually going to look like. Now, in the past you maybe would have had to write a lot of the graphics yourself, and then only at this stage, after writing a lot of code, will you be able to see your models and see what the images and the shaders that you've written will actually look like. We provide a tool called PBR Shaman. It's a shader editor tool. It's in full IDE. It has its own effects format, and it will take the pod model format that we provide and PBR texture format that we provide, and combine all these so that you can edit your shaders and see the results of your changes in real time. You hit compile and you see your changes on the screen. You can explore your scenes, rotate your models, and see how your changes are affecting the actual output image without having to write a single line of code beyond your shaders. One also crucial aspect of this tool is the inbuilt shader editor. Now, it's a full-on text editor. It's got the usual things like syntax highlighting. It will tell you when you've made a mistake in your shaders, etc. But crucially, it provides cycle counts, instruction counts per line, giving some idea of how expensive your shaders have been per line, so that you can start optimizing your shaders before they ever get anywhere near the device. And this is running from an offline compiler. We've just upgraded this compiler so that the output is even more accurate. We have a second total figure, and this tries to take into account things like stalls for texture reads and other things which aren't so obvious from just the instructions, so that the output is a lot more relevant to how the shader was performed in your actual application. Once you've got your scene running in Shaman and you've seen how your assets are going to look, you will need to write your applications in code in the bada environment. And for this, we provide you a lot of source code. These are projects which fit in with the bada SDK. And they take you from a single triangle all the way up to a complicated, visually rich effect. And you can start writing these on your desktop computer. They will run under our own emulation environment and the bada simulator as well, so that you can start coding your applications, whether it's a game or an UI or navigation system, on your desktop PC, and you don't have to go through the hassle of deploying the device over and over again. You don't necessarily have to have many devices in your development team, or even have a single one. You can get started straight away. And the emulation environment that we provide is called PBR VFrame. We also support the bada simulator. As I said, there's a lot of source code that we provide to help you with this. So we even provide you with a full-on kind of simple engine, which will play the scenes that the PBR Shaman IDE displays. So you can even see how these will look on a device and in an emulation without ever writing a single line of code. The other really important part of the source code that we provide is the PBR shell abstraction layer. This allows you to target all the platforms that Power BI supports, and this is what we use internally to provide the SDK for every platform that has Power BI hardware. So if you have an application for bada, say you want to target another platform, you're not locked in to the bada environment, with a simple recompile, you can target a different environments such as Android, if you're interested in one of, say, Samsung's Android phones as well. Now, once you've got your application running on the device, it may not run as fast as you want straight away. And so we provide performance tools. We have two major ones. That's PVR Tune, which gives actual statistics from the silicon inside the phone. Counters are being filled in there whenever the graphics are running with almost no performance overhead. In fact, it's so negligible that we don't even disable this in any of our chips. And so you can get performance figures from this as the phone is running, and you can see exactly where the chip may be struggling with some of your scenes, where you can add more features, or whether you might want to cut down so that the application will run faster. We also have a fairly new application known as PVR Trace, which will trace every call that you make into the OpenJLES API. And that way you can tell if you're making redundant state changes, if you're doing things that you don't need to do, or if you're just making too many calls. You can look. We found it's useful already on some code to discover people are calling GL error in their release code. There's no need to do this in release code. It may slow down the driver, but you can tell immediately that this is happening by running a trace. There's no need to look through all your code to find it. And we're adding features to this tool so that you can see how your textures are in memory. You will be able to edit shaders, like pausing your application. You can change the shader to see how your scene is affected by the changes that you've made, and you can read the performance output from PVR2. This is the kind of thing that's coming. So you have a very powerful arsenal of tools in order to produce the best applications that you can. Now, as I've mentioned, we provide a lot of source code. And the key thing to understand here is that if you're an inexperienced 3D developer, we really take you from... we used to do a blank screen tutorial, but to be honest, adding a single triangle wasn't that much more. So we start from a single triangle, and we go all the way through to very sophisticated effects. Now, if you're an experienced developer and you just want to know how to do a specific thing, all the examples are done in a very similar environment, very similar structure. So you can cherry pick off the shelf the effects that you're interested in, see how we've implemented them, and we're providing documentation with these to give explanations of why we might particularly do something in the way that we've done. We also have more fully fleshed out examples from the right here. We call them, they're known as demos. The ones on the left are known as training courses, and these are more, fleshed out examples of rich techniques. And full source code is provided for these, which we're currently filling in white papers for every one of these techniques, so that you have documentation and suggestions how you might want to do it differently, and reasons why we've done things in particular ways with these demos. Now, where do you get all this stuff? The SDK is part of our Power VR Insider program, and the address for that's at the top here. It's also linked to from Bada's developer site. One thing crucial to put here is that it's free to join. All you have to do is choose a username and a password, sign in, and then you have access to all the benefits that are listed at the bottom of the slide here. It's not just the SDK downloads. There's a lot of documentation, guidelines. We have FAQs. You get access to our developer forums, which have thousands of posts on them now, and these are moderated by the guys who actually write the SDKs. That's me. I believe I have the highest post count on this forum, although the guy who works with me is catching up, so I maybe should get on with it when I get back from here. We have a lot of very knowledgeable people moderating these forums and answering questions here, and sometimes they're not even from imagination. If that isn't enough for your company, if you want something a bit more confidential, then you can directly email my office with the address there, devtech@imgtech.com, and we will provide support directly across the email. It's been a very successful technique, and we do that. We will answer questions from a student writing a master's thesis all the way through to some of the biggest game developers in the world. We offer a partner program. For instance, at this show, we have an area on our stand with various partners exhibiting their stuff so that they can show the great things that they've done with our hardware. And this is good for us because if they show our hardware performing very well, then it only makes us look better, and we can make more licenses and more deals, sell more chips, and so it's a win-win situation. And we want you guys to come to us with great applications that we can show off that use PowerVR 3D hardware. And obviously you get things like newsletters and kind of cross promotions that any kind of media partners do. This year we're likely to run training programs. If you're particularly interested, you can get in touch through that email address, and we may be doing developer days just for the graphics, and if, for some companies we'll go out and give training, or you can come visit us and we'll give you some hints of how to use the hardware effectively and explain some of the topics that come up when you're using 3D. So I thought I'd put some examples of our PowerVR insiders and the kind of stuff they're creating here. The company on the top left, they're Digital Legends, are a Barcelona company, in fact, and we've been we've had a lot of good collaborations with them. They're actually, they made the main demo for us last year, and they made the main demo this year. I'm going to show you this now. So I'm really showing this. We commissioned this demo. This is written, as I say, by a third party. This isn't done with any backdoor entrances to the hardware. There's no special secret code here. Obviously, we support these guys. Sadly, the frame rate's gone down a bit here. This runs at 60 frames per second on real hardware. Apparently not in the video on my MacBook. Okay, it's recovered a bit. And you can see the kind of rich concept that you can put into your 3D scenes. You notice the shadows on the character as well as on the ground. The character is rendered with hardware skinning. There's bump maps on there. If you watch again, she will run in front of the city block building. You'll see reflections. That's in the metal there. And there's actually HDR light effects in this, and this is all on an embedded mobile chip. And this is the kind of thing that we expect to be rolling out by the end of this year and possibly next year, and this will be in the palm of your hand. So another area of application development is the user interface application or layer. And so here's some examples of the partners we have here. I'm also going to show you a video of the kind of user interfaces which are possible using PowerVR hardware. This is a company called TAT. As you can see, the user interface doesn't just need to be a few rectangles in a two-dimensional space. Rich 3D content is possible. And notice some of the lighting effects on these polygons. One of the innovations that we are encouraging now is that, not just to have static frames in these rectangles, but to have a movie, because to combine PowerVR graphics with PowerVR video. And so you can show multiple video streams inside the 3D API. And another application area that we're very interested in, and which has been a new addition to our SDK, is in navigation programs. We offer a tutorial and an extensive document describing how to render so-called 2.5D navigation techniques. This is maps, say from a kind of bird's eye viewpoint. And no longer, if you've ever been driving along a road and you've got to an intersection and the frame rate of your navigation has let you down, it hasn't updated in time for you to realize when you needed to turn off the junction that you're on. You benefit from the kind of techniques that we're producing, where we can run these things at 60 frames per second. It's in real time. What I'd like to show you is our latest demo, which is 3D navigation that we've produced. Now, all the source code is available for this. There's an extensive document describing how we've implemented this. Let's say it runs on real navigation data, and we've actually provided an example of this in the SDK. So you can download all of this for free at the end of the month, and it will show how to produce this kind of navigation demo. Application of that. And this one isn't a video, this is a real demo. This is running on our emulation layer. You can see the shadows, can be switched on and off. And this is just one technique we added to try and make the whole experience much more rich and interesting. You can see the kind of volumes that we've used to add these shadows, for instance. And all this is described in the document that goes with this demo. So, as I say, we like to think that we offer a solution from transistors all the way up to consumer devices and the applications that you guys develop, and also assistance to developers all the way from the very first triangle all the way to incredibly rich and varied 3D applications. And as I say, bada is a first-class member of the PowerVR Insider ecosystem. The SDK that we have for bada is fully featured, and we will help whatever developers are interested in that. And as I say, we are providing content for the bada website. Check PowerVRInside.com for the latest SDKs. And you can come visit us at this show. We're in Hall 1 with 1D45. That's in the main corridor in the middle. And we're also exhibiting at GDC this year. I will be speaking about how PowerVR hardware works, about our optimization tools, which should be more easily available. We should have an announcement for that at the end of the month. Okay, so thank you.